Hello everyone. In this video we will learn about the section formulae. Section formulae means what? The section means making parts of something. Here we will be making the parts of a line. It means we will be finding the coordinates of a point which divides a given line joining two points in a given ratio. What type of divisions? When we divide any of the line, there can be made the division of a line in two different ways. Division of a line there are two different type of divisions. One is internal division. What is internal division? In case we have a line AB joining these 2 points A and B, and there is a point P in between A and B, such that this divides in the ratio of m:n. It means PA upon PB is equal to m/n. Then we say this is the internal division. The second type of division is external division. What is external division? In case we have a line AB joining 2 points and we find a point on producing this AB to P, such that the ratio of PA is to PB is m:n. It means here also we find PA upon PB is equal to m/n. It is not necessary that the line is to be produced on the side of B only. It may be produced on the side of A also. Let's see if there is a line AB joining 2 points A and B and we find the production of this towards A, and there is a point Q such that the ratio of QA to QB is m:n. So we find here QA upon QB is equal to m:n. Then also it is the external division. We have to find out the coordinates of the point which is dividing the line in the given ratio either internally or externally. Now to learn about the section formula for internal division. We take any 2 points P and Q. The coordinates of P are suppose x1, y1 and that of Q are x2, y2. And the point of division, that is R, dividing this in the ratio of m:n. Suppose the coordinates of R are x, y. The coordinates of P, x1, y1. Q, x2, y2. And we have taken the ratio is m:n. The point of division we are taking R and the coordinates of this are suppose x, y. We have to find out the coordinates of x and y. How to do that? We draw perpendiculars from P, Q and R onto the x-axis. The perpendicular from P is PL, that from Q is QM, and the perpendicular from R is RN. A perpendicular from P to Rn, that is PS, is drawn, and a perpendicular from R to QM, that is RT, is drawn. Can we find out OL? We know OL is the x coordinate of P, that is x1. OM is the x coordinate of Q, that is x2. And ON is the x coordinate of r, and that is x. Can we find out ln? We can see here ln is equal to x minus x1. What about mn? mn is x2 minus x, and lm is equal to x2 minus x1. Similarly, we can see here PL is the y coordinate of P, that is y1. Rn is the y coordinate of this R, and that is y. The y coordinate of Q, that is here, that is y2. From this, can we find out the length of RS? We can see here RS will be y minus y1. What about QT? QT will be y2 minus y. Now we can see easily that this is a right triangle. This is also a right triangle. And these angles are equal, they are corresponding angles. So we can say that triangle PSR is similar to triangle RTQ by AA similarity criterion. And if they are similar, then the corresponding sides of them will be proportional to each other. So can we say then that PS upon RT is equal to RS upon QT is equal to M upon N? If we take the first and the third part, we are getting PS upon RT is equal to M upon N, which implies that PS, what is PS? That is x minus x1, because that is equal to ln. So that is equal to x minus x1. What about RT? RT is same as Mn, and that is equal to x2 minus x. x2 minus x, that is equal to M upon N. We can also write here that PS is equal to ln. ln is equal to PS. We can write here Mn. Mn is equal to RT. So that we can apply them here. If we cross multiply them, we are getting M into x2 minus M into x equal to N into x minus N into x1. If we transpose, we can get here M into x2 plus N into x1 equal to M into x plus N into x, or not? It means we are getting from here mx2 plus nx1 equal to m plus n into x. We have taken x common, and from this we get the value of x as mx2 plus nx1 upon m plus n. This is the x coordinate of point R. Similarly, if we go over the second and third, we have Rs upon Qt equal to M upon N. What is Rs? That is y minus y1. What is Qt? That is y2 minus y is equal to M upon N. And if we cross multiply them and simplify the same way, we will be getting y is equal to my2 plus ny1 upon m plus n. It means we are getting the coordinates of R as mx2 plus nx1 upon m plus n, my2 plus ny1 upon m plus n. This is known as the section formula for internal division. Now how to remember this easily? See, m, this ratio into x2, the coordinate of q, plus n into the coordinate of p upon the sum of the ratio. Same for y. Like this we can remember the section formula for internal division very easily. So we have learned the section formula for internal division, in which we found that the x coordinate of the point of division is given by mx2 plus nx1 upon m plus n. The y coordinate is given by my2 plus ny1 upon m plus n. In case we want to learn the section formula for external division, we will draw the diagram here also in this case. P is x1 y1, Q is x2 y2, the ratio is m is to n, and the point of division is R. We consider the coordinates of R are x, y. We are considering this. Suppose the diagram is drawn the same way. We draw the perpendiculars from P, Q and R onto the x-axis. Then we draw a perpendicular from P to Rn and from Q to Rn. The same thing we did in the previous, that is in the section formula for internal division also. Then finding these distances Lm, Mn, Ps, Qt, Rt and Rs. If we substitute in that the same way, because this time triangle PSR and QTR are similar, then we will get the formula x will be mx2 minus nx1 upon m minus n. Y will be equal to my2 minus ny1 upon m minus n. So the difference between the two we are finding that in place of plus, the sign here become minus. So easily we can remember the formula for external division also. Before proceeding further, subscribe the channel to get more videos on concepts of different topics of mathematics. To understand about the application of the section formulae, we will discuss some of the examples. The first example we discuss here is find the point which divides the join of 2, 5 and minus 5, minus 2 in the ratio 3:4 internally. For the solution of such problem, we will write the points which have been given to us. So we write the given points. A is 2, 5 and B is minus 5, minus 2. The ratio in which we have to find the division, that is 3:4, and we can consider the coordinates of the point of division. So we can write, let the point of division be P, that is x, y. Then we write the formula. X is equal to mx2 plus nx1 upon m plus n, and we substitute the values. M is 3, x2 is minus 5 plus n is 4 and x1 is 2 upon m plus n, that is 3 plus 4. We simplify. This is minus 15 plus 8 upon 7, which gives us minus 7 upon 7, which is minus 1. Now we write the formula for y, that is my2 plus ny1 upon m plus n. Substitute the values. M is 3, y2 is minus 2 plus n is 4, y1 is 5 upon m plus n, that is 3 plus 4. Simplifying this, we get minus 6 plus 20 upon 7, which is 14 upon 7, it is 2. It means we get the point of division, that is equal to minus 1 comma 2. If we are to find out the ratio in which a given point divides a line segment joining two given points, then let's discuss one of the problem based on that. And that is, in what ratio does the point 2 comma minus 5 divide the line segment joining A minus 3 comma 5 and B 4 comma minus 9. For the solution, we write the points which have been given to us. A is minus 3, 5, B is 4, minus 9, and the point of division P, that is 2 comma minus 5. Suppose P divides AB in the ratio k is to 1. We have to consider some of the ratio. So we write, let the ratio in which P divides AB be k is to 1. Instead of taking m is to n, we can take k is to 1, and finding the value of k, we can get the ratio. Now we write the section formula. What is that? X is equal to mx2 plus nx1 upon m plus n. And we substitute it here. What is x? 2. M is k into x2, that is 4, plus n, that is 1, into x1, that is minus 3 upon m plus n, means k plus 1. Cross multiply this, we are getting 2k plus 2 equal to 4k minus 3. Transposing, we are getting 2k minus 4k equal to minus 3 minus 2. That gives us minus 2k equal to minus 5, or we get k is equal to 5 upon 2. K is 5 upon 2, therefore k is to 1 will be 5 upon 2 is to 1, or we can say 5 is to 2. And hence we can say, therefore the ratio in which P divides is 5 is to 2. Here we should learn one more thing, that if k is less than 0, or we say negative, then P divides AB externally. It means if the ratio comes negative, we should not get confused. We can understand that the point is dividing the line externally. In the next video, we will learn how to find out the coordinates of midpoint of a line joining two points and also the centroid of a triangle. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.